a video about the lab that we're working on for this unit. Um, and so this is one of the, I think, more interesting and exciting labs we do in the class. This has to do with using GIS and suitability analysis to find places where landslides can occur. So this is a pretty specific example. I got this lab from a lady I know that works for Esri, and the data and this example, it all deals in California, specifically in the San Bernardino, California area. And we know that this area is susceptible to landslides, especially up in the hills and the mountains. And so that's what this lab is going to do, is figure out what areas are most susceptible. And so to start off with, I've downloaded the data from the Moodle site. So again, Unit 7 Suitability Analysis. I've downloaded the data here. And then you also need to download the DEM to complete this lab. So there's two things you need to download, the data and then the DEM. And I have just downloaded them and put them on my desktop. So here is the data and here is the DEM. And I went ahead and created an ArcMap Pro project called Landslide Map, and I've saved the project to my desktop, and here's the folder for the project right here. But I've loaded in all of the data, so we have schools, streams, roads. SB, by the way, stands for San Bernardino. We have fault lines, and then we have some burn areas. So this area was some fires went through, and we'll talk about how fires can lead to landslides. And then I simply have the California boundary, the state boundary, and then here is the DEM that you need to download. Okay, so starting off here, we're just looking at California. This is the outline of the states. All of the data that we have specifically for San Bernardino is down here. So San Bernardino, as you can see, is east of Los Angeles, kind of up in the hills or the mountains there. I'm just going to kind of zoom in here on the data so that you can see what's going on here. I'm going to turn some of these things off and just explain what's going on. So first of all, we're looking at this is the DEM, okay? So DEM stands for Digital Elevation Model. And so obviously a DEM is a raster data, so it's made up of cells, and each cell is attributed with a number, and that number is the distance above sea level. In this case, here are the numbers right here. So the black areas, you can see the lowest value we have is 335, and then the highest area, the white areas, is 1,968. Now, if you right-click on this DEM and go to Properties and go to Source, and then go to Raster Information, you can see some information about this raster. Our cell size is 10 across and 10 up and down, which means it's 100 square of something, and we'll get to what the units are here in a minute. But each cell is a 10 distance cell. Now, if we want to know 10 of what kind of units we're looking at, then we need to go to Spatial Reference, and you can see here that this DEM is in meters. Okay, so it's in UTM and it's using meters. So if we scroll back up here, what this means is each cell is 10 by 10 meters. So each cell occupies 100 square meters on the ground. Okay, so pretty good DEM. This is what we would call medium resolution. Not the greatest, but certainly better than a 30-meter DEM, for example. So just some information about this digital elevation model. Also, if we look at these numbers are in meters. So these numbers are meters above sea level. Okay, so if you kind of wanted to get an idea of feet above sea level, which is what we're in the United States kind of used to looking at sea level numbers at, you would just kind of need to multiply these numbers by 3.28. That's how many feet are in a meter. Okay. So again, digital elevation model, and we can kind of do some things here. We can go up to, oh, let me see, appearance. So I have the DEM highlighted. We can go to appearance, and we can kind of make this transparent so you can start to see the aerial photo behind the DEM if you want to. Okay, so that's the DEM. Next we have the burn data. Okay, so if I turn that on, it's all just one color. These are areas that were burnt by a fire that went through. Okay, and if we open up the attribute table of this data, there's a lot of stuff in here that I don't even know what it is. But the one piece of information that is going to be useful to us is this veg burn sev, and that stands for vegetation burn severity. And so it's just populated with kind of a qualitative comment of low, moderate, or high. So if it was highly burnt, moderately burnt, or not very, it wasn't burnt very much at all, that would be low. So let's go ahead and symbolize this burn data on that column. So again, I would highlight the burn data. I'm going to go to symbology, go to the appearance tab, click symbology, and I'm going to go to unique values. And I'm going to choose that veg burn sev column. Okay. And you can see there it occupies the low, or the high, low, and moderate. And then all other values, which there aren't any. But I'm just going to go ahead, so let's give some appropriate colors. So an area that would be highly burnt, I'm going to give it a red color. And for an area that's low, not very much burnt at all, I'm going to give it kind of maybe a green color, sort of. And then for the moderately burnt areas, maybe an orange or a yellow. Okay. And so now you can see the different areas that, again, low, moderate, and high. And again, we can highlight this over in the table of contents. We can go to appearance, and we can make this transparent if we wanted to. Okay. And you can turn the DEM on and off. So you can see a lot of this area is up in the hills above San Bernardino. This is San Bernardino here. These are the hills kind of to the north and east of San Bernardino. Okay. Some other pieces of data that we have that we'll use later on. We've got fault lines that you can see here. We've got the roads for this area, streams, and then we've got some schools, the schools in the San Bernardino area. For now, I'm just going to turn this data off. Really, the two pieces of data that we're going to use for this analysis to start off with is the DEM and the burn severity. Okay. Okay, so there are a lot of factors that can go into where a landslide would most likely occur. In this particular lab that you're going to read, and I have the lab pulled up here, the Word document. If you read through this, there's going to be three things that we're going to use as factors of where landslides can occur. The first is going to be slope. Okay, obviously you can't have a landslide unless it's kind of on a hill with some slope. So we're going to create slope data from the DEM. Okay, and I'll show you how to do that in a second. The second factor we're going to use is aspect. And if you don't know what aspect is, that is the direction the slope is facing. So whether the slope is facing north, south, east, or west. Okay. The lady that made this lab from Esri believes that south-facing slopes are more susceptible to landslides, and we'll talk about why that is here in a second. And then the last thing we're going to do is, or use, the third the third factor in figuring out where landslides occur is we're going to use burn data, okay? So obviously when a fire goes through and burns vegetation, there's nothing there anymore to hold the soil together. So again, Esri made this lab, and they're thinking, the lady that made this lab that works for Esri, obviously, and this makes sense, where there's no vegetation, there's going to be a higher susceptibility of a landslide because there's nothing there to hold the soil together, okay? So again, three factors we're going to look at: slope, aspect, and the burn data, okay? So first thing we're going to deal with is let's deal with slope, okay? And so in terms of the lab, basically where I am starting at would be, let's see here, step 7 on page 6, okay? Oh, and then the last thing I should point out is you can use raster and vector data in a suitability analysis, but ultimately everything has to be turned to raster data. So our DEM is raster data, but notice our vegetation, our burn data is vector. So we have to convert that to raster. And actually, if I look back at the lab, if I remember right, I guess step 6, the first thing we do is convert the veg burn data to a raster. So you can see here on page 6, so before step 7, which would be step 6, we're going to convert the vegetation data to raster. Okay, so let's start off by doing that. Okay, so first thing, again, the veg burn severity data is vector. We need to convert to raster. So I am going to go up to analysis. I'm going to go to tools. And I'm going to find the tool that we convert polygon to raster, okay, because these are polygons, okay, so, and here's the tool, polygon to raster. So I'm going to click on it. My input feature is obviously going to be the San Bernardino burn severity. Now here's where I need to pick a value in the attribute table to convert on. Remember, the value, the column in the attribute table that we're using is this veg burn sev. Okay, so that's what I'm going to select here. And I need to tell it where to save this new raster. So I'm going to hit the browse button, and I'm going to save it in my project folder on the desktop. Okay. You can choose to save it where you want. Maybe you'll want to save it in the LS data folder. I am going to choose to save it in my landslide projects. Okay, so I'm going to double click that, and then I'm going to name it. Okay, so I'm going to call this burn raster. The lab has you call it something else, SB burn sev, I believe. You can call it whatever you like. You don't have to follow the lab in terms of names. Okay. Okay, here we go. The next thing that's important here is remember the cell size that we're working with in the DEM. Right? If you remember, the DEM cell size was 10 by 10. Okay, so for the cell size here, we have to put in 10 because we want to convert this to a 10-meter raster. Okay. So I'm going to put in 10. Looks like everything's good to go. I'm going to click run. Okay, and now you can see we have a raster. And if I put, and as you can see, if I zoom in here, right, maybe I'll turn, so as you can see here, I have the vector data above the raster data. Notice it's a smooth line. This is vector data, but when I turn that off, you can definitely see this is now a raster. Notice how the lines follow the cells, the shape of the cells now, not the smooth vector line, okay? So it doesn't look like anything is different, except when you zoom in, you can definitely tell this is now a raster, okay? What I like to do, since I just converted that and I don't need this anymore, I am going to delete out the old vector data, the burn vector data. I don't need it anymore just to keep my map clean. So I'm going to right click and remove it, okay? So we've converted that. It's in raster form. We're good to go, okay? The next part of the lab, step 7, is we are going to create some slope data. Okay, I'm going to turn off my burn data here. I'm going to turn on the DEM, and we are going to create slope data from the DEM, okay? Because remember, slope was one of our factors, okay? So I'm going to go up to Analysis, Tools. I'm just going to simply type in the word slope. And we want to use the Slope Spatial Analyst tool. So my input raster is going to be the SBDEM1 because that's where slope comes from, is a DEM. I am going to save it in my landslide project folder, and I'm going to call this just simply SB slope. Remember, SB stands for San Bernardino. I want it in degrees, okay, and I'm just going to click Run. Okay, now you can see we've got slope data. So these numbers are in degrees, right? So just so you know, a 0-degree slope would be a flat area. A 90-degree slope would be a cliff that's straight up and down. Okay, so that's what we're working with here. The last thing we're going to do is we're going to create our aspect data. Okay, remember, aspect is the direction the slope is facing, and that comes from the DEM as well. So again, I'm going to go up to the top, Analysis, Tools, and I am going to search for aspect. And again, we're going to use Aspect Spatial Analyst. So I'm going to click the tool. My input raster is the DEM. I'm going to save this in my project folder, and I'm going to call this SB aspect. And I'm going to run the tool. And there you can see we've got a really funky looking piece of data here, but it is the direction that each slope is facing, okay? So if it's a north-facing slope, again on a compass, 0 to 22.5 degrees on a compass, it's colored red, so on and so forth, okay? You'll notice there's 2 norths because obviously on a compass, north is 0 and north is also 360. So there's kind of 2 options on a compass of where north falls into, okay? So we've got our aspect, we've got slope, we've got our burn data. I no longer need the DEM, so I'm going to remove it. Okay, I'm going to right click on the DEM and remove it. Okay, we've got our 3 factors for our landslides. Slope, burn data, and aspect. Okay, now we are at step 7. Okay, I'm not quite following the Word document in the lab, okay, but if you watch this video, I'm pretty sure you're going to get the gist of what's going on here. But we've created our slope, aspect, and burn data, and now we have to kind of what's called reclassify our data. So step 7, we're reclassifying the slope data, okay? And we're going to split the slope numbers into break values. So 0 to 5 degrees, 5 to 10, 10 to 15, so on and so forth, okay? And so to do that, we are going to use the Reclassify tool, okay? And we're going to split the numbers up into these values right here, okay? So I'm going to go up to Analysis Tools. I'm going to type in Reclassify, and we want to use the Spatial Analyst tool, so I'm going to click Reclassify there. My input raster is going to be slope. Okay, my input raster is slope, reclass field value, and then what we're going to do is click Classify, and we're going to classify this data into 6 classes. Okay, and so again, we're going to follow what the lab here. These are our 6 values: 5, 10, 15, 25, 33, and 81. Okay, so hopefully I can remember that here. So 5, 0, 2, 5, 5 to 10, 10 to 15, 15, let me go back to my Word document, 15 to 25, 25 to 33, and then we have 33, and the highest value we have is 80.9, so just to be safe, we're going to make that 81. Okay. Now, the next thing we're going to do with those 6 classes is we're going to rank the classes between 1 and 6. Okay. So we are ranking the areas that we think are most susceptible to landslides 1 through 6. 1 being areas that don't have much potential for a landslide, 6 being areas that have a lot of potential. And if you look at this picture right here in the Word document, you can see 0 to 5 is a 1, 5 to 10 is 2, so on and so forth, until the steepest areas on our slope data are characterized with a 6. Okay, so let me go ahead and do that. Well, and you can see it already has it done, 1 through 6. Okay. Let's go ahead and save this new. So it's going to create a whole new raster from the slope data. Okay. So I'm going to hit the Browse button. I'm going to save it in my landslide project, and I'm going to call this SB Slope RC. Okay, RC stands for Reclassify because we are using the Reclassify tool. Okay, I'm going to go ahead and click Run. All right. You can see here, this is our new slope data. You can see we have 6 classes. 1, and this kind of makes sense. Remember where the city is, it's attributed with a 1. Remember that was flat. It was 0 to 5 degrees. Okay. All the way up to 6, which are these purple areas, those are the 33 to 81, and they're classified again with a 6. Okay. I am done with the original slope data. We took it and we reclassified the data. I'm going to right click on the slope data and remove it just to keep my map and project looking clean and organized. Okay. The next thing we're going to do, let's go back to the Word document. So again, step 7, we took the slope data and reclassified it. The next thing we are going to do, I believe, is the aspect. We're going to use the Reclassify tool and reclassify the aspect. So again, now we're on page 7 here. Now you reclassify aspect using the same tool you did for slope. Double click Reclassify tool. Our input is going to be aspect. And then we're going to click the Classify button, and we're going to do 9 classes. Okay. And then notice the table here. This is how, remember, aspect of this is the direction the slope is facing. Okay. So we're going to split the data up into these 9 classes. So let's go ahead and do that first. I have my Reclassify tool up already. I'm going to choose Aspect as my input. We're going to click Classify, and yep, we want 9 classes. Okay, I found out I had to pause there for a second, but I had to close the tool. So you need to close the tool and then go back in and reopen the Reclassify tool up. Okay, my input raster is going to be aspect, and then I'm going to hit classify, and we are going to do 9 classes. Okay, and then we're just going to follow this table here. Okay, so an aspect with direction of 0 to 90, so that's an east-facing slope. It's going to get a value of 0. Remember, this lab says that south-facing slopes, and the reason is south-facing slopes are thought to be drier because in the northern hemisphere, the sun hits south-facing slopes the most. Okay, so they're going to get a 6. They are the most susceptible to landslides. Southeast and southwest facing slopes are going to get a 3, and then north, northeast, and northwest slopes are going to get a 1 and a 0. Okay, so again, south facing slopes get a 6 here. Okay, so we're going to copy this table in our GIS exactly. So -1 to 0. Sorry, I'm going to have to switch back and forth here. And that new value is a 0. Zero to 90 is a 0. '90 to 120 is a 1. I believe the next one is 120 to 150. I believe that is a 3. Yep. $150 to 180 is a 6. $180 to, I believe it is 210. Yep, it's a 6. 210 to 240 is a 3. 240 to 270 I believe is a 1, is that right? Yep, 1, and then 270 to 360. Is a 0. And then I'm going to save this new raster, and I am going to call it SB aspect underscore RC for reclass. I'm going to save it and run it. And there you go. So there you can see 0, 1, 3, and 6. We've classified the direction of slope as to what we think is the most susceptible to landslides. Again, the blue areas are the south-facing slopes, and they're characterized with a 6. Okay. The next step. Okay, the next step is we are going to, well, let me back up. I've reclassified my aspect data, so I'm going to get rid of the original aspect data. I'm going to right-click and remove it, again, just to keep my map project clean. Okay. Now we are ready to combine aspect, slope, and the burn data into the areas that we feel are going to get or are the most susceptible to landslides. Now, one thing I want to point out is we haven't reclassified the burn data at all. And if we open up the attribute table for the burn data, you will see that the low areas already have a value of 1, the moderate areas a 2, and the high areas a 3. So while fire does affect landslides, The lab is only saying that high areas get a ranking of 3. Okay, not a 6, just a 3. Moderate areas a 2, and a low area is a 1. Okay, so we don't need to do anything with the burn data. So how do we combine these 3 data sets? Okay, so we're going to use a tool. So I'm going to click Analysis, Tools, and I'm going to search for a tool called Raster Calculator. And we're going to use the Spatial Analyst tool, Raster Calculator. So I'm going to click on that. I'm going to stretch it out here if I can. So what Raster Calculator allows you to do is perform a mathematical function on GIS data. Okay, and as you can see, if you follow the lab here, this is the equation we're going to use to combine all 3 of those pieces of data. So I'm on page 9 of the lab, okay? And each piece of data gets sort of more of a weighting than the other. For example, we are going to take the slope data and give it a weighting of 60%, because slope is the most important factor in this analysis, okay? So it gets 60% of the weighting in this analysis. So we're going to take slope, multiply it by 0.6, add that to the aspect data, which is going to get multiplied by 20 by 0.2. We're going to add that to the burn data, which also gets multiplied by 0.2. So we are saying slope is 60% of the weighting, aspect and burn data are each 20% of the weighting of the analysis. So aspect and burn data are important, but not as important as the slope data. Okay, that's why we're multiplying those 2 by 0.2 and the slope data by 0.6. Okay, so let's go ahead and put this equation in the raster calculator. So we're going to take the slope data, reclassified slope data, we're going to double click the multiply sign, and we're going to hit a space, and we're going to do 0.6. Okay? And then we are going to add that to the aspect data, and that is going to be multiplied by a 0.2. Notice I'm putting a space in between everything. Okay? Then we're going to add that to the burn raster, and that's going to be multiplied by 0.2. Okay? And then this new raster that it's going to make, I believe the lab tells you to save it as high sus, which stands for high susceptibility. Okay? So high underscore sus. And then we're going to click run. Okay, I'm going to turn off the other rasters, and in fact, I am going to remove them. I'm going to remove the burn raster, the slope reclassified, and the aspect reclassified. I'm going to remove them as I don't need them anymore. Okay? So you can see here, it looks kind of weird and cloudy here, but these are the areas that are the most susceptible to landslides. They range from a 0.8, which are the flat areas, to a 5.4. Remember, this scale is between 0 and 6. Okay, so the white areas are a 5.4. So those would be the highest areas, or the areas that are susceptible to landslides the most. Okay, now the lab has you go in next and pull out everything that's 4.8 or higher. Okay, so we're going to put this equation into raster calculator. Okay. So I'm going to remove the old equation, and we're going to go high sus, so double click it, and then the greater than sign, double click greater than, and then put a space, and then 4.8. So it's going to pull out everything that's 4.8 or higher, and we're going to call this final. Okay, I'm going to remove the high sus raster now. I don't need it anymore. Now we can see anything with a 1, okay, are the areas that are 4.8 or greater. Right? Anything with a 0 is anything less than 4.8. So let's get rid of this purple area, anything that's a 0. So let's go up here to Final, click Appearance, click Symbology, and let's go to Classify, or excuse me, let's go to, I'm sorry, Unique Values. And we are going to highlight anything in the 0 column, and I'm going to hit this X that says to remove it. Well, it removed all of them. Okay, so I hit the X to remove it all. Let's hit the add number, and let's just add the 1 value. So highlight 1 and click OK. And so you can see we just have the 1 values now. I'm going to make those red. And instead of just a 1, I'm going to call this highest. You can see it change that in my attribute table. So we're left with all the areas that we feel in our analysis are the areas with the highest susceptibility of landslides, and these are the red areas. Okay, and in the lab, it says to print the map. Obviously, I don't want you to print it. Put this on. Make a PDF out of this map and email it to me in Moodle. Okay, email it to me in Moodle. And there are no questions to answer in this lab, I don't believe. No, there are no questions. I think it says there are, but there are no questions to answer in the lab. But for your map, I mean, let's add the streams and the roads and the schools, okay? And let's think about, just real quick, who would be interested in a map like this, right? So insurance companies would be interested in a map. If someone wants to build a house within these areas, obviously their insurance is going to go up. City planners would be interested in a map like this to know where they don't want to build roads or infrastructure or houses or communities in these areas that are highest susceptibility to landslides. So as you can see, there would be a lot of people that would be interested in data like this, okay? I know this was kind of a lengthy video, but I wanted to make sure and explain the process to you, and as always, make sure you get a hold of me if you have questions. So thanks everyone, and good luck on the unit.